Hello, and this is going to be about derivatives of trigonometric functions. So, one thing that we start with is by looking at the limit as x approaches 0 of sine of x divided by x. Now, we showed that in this limit we have that this equals to 1, and we also have that if we take the limit as x approaches 0 for, we'll say like this, 1 minus cosine of x divided by x, that equals to 0. Now we're going to need these in order to verify that our derivatives of sine of x is equal to cosine of x, and that the derivative of cosine of x is equal to minus sine of x. Now, what we can do here is just kind of like work with these just a little bit. So for example, let's say that we wanted to show the derivative for sine of x. Well, we know that basically that this derivative would have to be equal to the limit as h approaches 0 of sine of x plus h minus sine of x all over h. Now, the way that you'll have to proceed with this is that you'll have to use the expansion formula for sine of a plus b, which is equal to sine of a cosine of b plus sine of b cosine of a. So this will be equal to the limit as h approaches 0 of sine of x cosine of h plus sine of h cosine of x. And all of this is minus sine of x, and all of this is divided by h. Why don't we go ahead and say, yeah, that this is divided by h, this is divided by h, and this is divided by h. If we kind of move some things around, you're basically going to see that, for instance, sine of x is constant, so sine of x multiplied by the limit as h approaches 0 of, and why don't we just change this to negative sign? That way we have 1 minus cosine of h divided by h plus, well, notice that we also have cosine of x multiplied by the limit as h approaches 0 for sine of h over h. But there's two things that I happen to know. I know that, for instance, that this right here is 0. I also know that that's 1. So I end up with negative sine x times 0 plus cosine of x times 1, which is actually just equal to cosine of x. So we know that the derivative of sine of x is cosine of x. Okay. Now, similarly, we can use that the derivative of cosine of x is equal to negative sine of x. I suggest that you go ahead and you try to show that these two are equal. How? You'll have to use the official definition and use that cosine of a plus b. So remember that cosine of a plus b is equal to cosine of a cosine of b minus sine of a sine of b, sine of b. Okay, so in that sense, that's just telling you that you just have to use the sum formula for cosine. Now, once you've basically have establish that the derivative of sine of x and that the derivative of cosine of x are as follows. So we have cosine of x and then we have negative sine of x. Once you've established this, basically you have that you can find the derivative of any trigonometric function. So with that, you could actually figure out like what is the derivative of tangent. So the derivative of tangent is given by using the derivative of sine of x divided by cosine of x, which if you use the quotient rule, you'll have cosine squared x, you'll have cosine of x multiplied by the derivative of sine x, which is just cosine of x, minus the derivative of cosine of x, which is just minus sine of x divided by, multiplied by sine of x. Now, one thing that you'll notice is that this gives you cosine squared x plus sine squared x divided by cosine squared x. Okay, there's a lot happening there. So for instance, I know that the sum of the squares, or cosine squared x plus sine squared x, is equal to 1 divided by cosine squared x. But that's also equal to secant squared x. So that means that the derivative of tangent is equal to, the derivative of tangent of x is equal to secant squared x. Now that means that basically you have the third function. So with that, that means that you could actually figure out the remaining. So for instance, if you take the derivative of, let's say, cosecant of x, the cosecant of x, because it's the same as 1 over sine, it's basically going to give you that you have, so if you change it to the derivative of 1 over sine of x, well, that's going to be negative cosine of x divided by sine squared x. But if you kind of move things around, basically it's going to give you minus cosecant x, and then you have cotangent of x. So it gives you that this is the derivative of that function. So we have that the derivative of cosecant of x is equal to negative cosecant of x cotangent u. Okay, so these can actually just be derived, just by changing it to its basic form, like sine and cosine. So the same thing goes for like if you have the derivative of secant of x, well, that's just 1 over cosine, which basically means that that's going to be secant of x tangent of x. So we have our other derivative of a trigonometric function, and then followed by the last remaining one, which is the derivative of cotangent of x. Now, nicely enough, we know that that's the derivative of 1 over tangent of x, which is basically just going to be negative secant squared x divided by tangent squared x. But in this case, that's going to give you negative 1 over cosine squared x divided by sine squared x divided by cosine squared x. But this is going to equal to negative cosecant squared x. So I have that the derivative of cotangent is actually just negative cosecant x. So you have the derivative, all right, is going to be equal to negative cosecant squared x. And that's the last of the remaining trigonometric functions. Now, of course, you have to keep in mind, like chain rule and those sorts of things. So as you're taking the derivatives of these functions, be sure that you do take into account the chain rule. So like, for example, let's say that you want to find the derivative of cosine of uh, x squared. Actually, sorry. Let's see. Actually, sorry about that. So I know that I mentioned that you need to be aware of chain rule, but that's for another section technically. So let's say that we have that we want to find the derivative of the exponential function e to the x times cosine of x. Well, this is going to be product rule, so this is going to be e to the x multiplied by cosine of x plus e to the x multiplied by the derivative of cosine of x, which is just negative sine of x. But basically this gives us that this is going to be e to the x multiplied by cosine of x minus sine of x. And then that would be it. Now notice that you could probably take some more derivatives from this, but it might get a little bit complicated. I also would recommend that you find horizontal tangents as it relates to trigonometric functions because, for example, I know that for this one, that if I set the derivative equal to 0, I have that e to the x is basically always positive, but then I have that cosine of x minus sine of x equals to 0. This is for when tangent tangent of x is equal to basically 1, which would mean that x is going to be equal to pi over 4. But in that case, it's going to be pi over 4 plus 2n pi, because it's going to repeat every single time. So you have that there's horizontal tangents at pi over 4 plus 2n pi. Actually, there's another place where it would be equal to 1 at. Yeah, there's one more. It's actually going to be 5 pi over 4 plus 2n pi. Okay. Yeah, because you want it to be in the third quadrant also. Now, you could probably come up with your own solution, like for example, to say that it's every pi, because in that case, that'll tell you that if you're looking for the horizontal tangents, that you know that it's going to occur right here at pi over 4. So this is right here, this is pi over 4. But then you also know that it's going to reoccur every single time that it passes through here. So that's going to be the 5 pi over 4. But then it's going to reoccur again when it comes around over here. So that means that if you probably just say pi, you might be able to get away with that, like n pi, because yeah, it's going to be basically every single 180 rotation in that case, for horizontal tangents, that is. Now, I'll go ahead and complete derivatives of a trigonometric functions because you deal with it more once you find chain rule or once you learn chain rule. So we'll just say that we want to find the derivative of sine of x divided by 1 minus cosine of x. Now here we know that we have to use quotient rule because you have that this is f and that's g. So that's going to be 1 minus cosine of x multiplied by the derivative of sine of x, which is just cosine of x, minus the derivative of the denominator, which is going to be positive sine of x multiplied by sine of x. Now, what this does is it gives you that when you simplify this even further, you have that this is going to be, oh, and all of this is divided by cosine, well, 1 minus cosine of x to the second power. So this is going to be cosine of x minus cosine squared x minus sine squared x, sine squared x, all divided by 1 minus cosine of x. Now, note that basically that this is just going to be cosine of x minus 1 divided by 1 minus cosine of x, but that's to the second power. But notice that basically this gives you that you end up with the simplification form of negative 1 divided by 1 minus cosine of x, and then that's it. Because you have that this right here was really negative times 1 minus cosine of x. Then from there, a factor of cosine, 1 minus cosine of x canceled out. Now, I would recommend that maybe you might try to find the second derivative. So I'll just say, for example, that that it's a good idea to go ahead and try finding the derivative of the result. So negative 1 over 1 minus cosine of x. Basically what you're going to find is that it's almost the same exact thing, but with the denominator squared in terms of the original function. Okay, so the main thing that you will have to remember for these is just the derivatives of your sine and cosine and so on. Now, note that if you were going to take the nth derivative of sine, like so if you take the derivative of sine of x, that's going to be cosine of x, but if you take the derivative of, okay, so if you take the derivative of cosine of x, that returns, or it becomes minus sine of x. But if you take the derivative of that, you have that's going to be minus cosine of x. But then again, you basically just take the derivative again. So if you take the derivative of minus cosine of x, it just becomes positive sine of x, which basically means that it depends on, how many derivatives you're taking, for instance, because I can tell that, the even number of derivatives. So like, for example, I know that that's the first, that's the second, that's the third, and that's the fourth. I know that basically at this point that essentially we have that the nth derivative with respect to x is equal to negative 1. Okay, so we have that it has to be an even number. So yeah, that should be 2n, not just the nth power. So let me just change this. Yeah, so we'll just change that. Okay, so we just have to make sure that this guy says x to the 2n, and then we have that that's going to be the second derivative. Okay, so in this case, this will just have to be negative 1 to the n. So we look at the first derivative, or when n equals 1, it'll be minus, and then we'll just put a sine of x. So that's kind of interesting that we can find higher order derivatives as well with respect to trigonometric functions. Try for cosine of x and so on.